Today's show is brought to you by Granulate, an Intel company, and their new offering, gMaestro. gMaestro allows you to reduce your Kubernetes costs by up to 60% with autonomous, continuous workload, and pod right-sizing. With gMaestro, you gain full visibility into your Kubernetes clusters and eliminate over-provisioning without compromising performance or affecting your competitive SLAs. gMaestro can be installed with a single line of code and provides visibility into inefficiencies within your Kubernetes clusters. Users can automatically apply HPA, CPU, and memory request changes that can be employed to save up to 60% on compute costs. And the best part, it's absolutely free. Try gMaestro yourself at granulate.io/gmaestro to begin optimizing your Kubernetes today. That's granulate.io/gmaestro to begin optimizing your Kubernetes today.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron back on news again this week. And for those that followed along, I did my first work travel in a number of years last week. Had sales kickoff for my company, was out in Las Vegas. So far, so good, knock on wood, no COVID, but had a good time, but also realized I completely forgot how to travel. Don't know how to pack, don't know how to fly, but we got through it. So with that, I'm going to jump into Cloud News of the Week. For our first article, a bit of an incident over at LastPass. If you're not familiar with it, LastPass, password encryption platform, if you will, and they actually have noticed some anomalies in their development environment and did a forensic analysis of everything and did come to discover in their development environment some of the source code was leaked. But nothing related to customer data, keys, anything else like that. So no exposure, no action items for anybody out there. Don't have to change passwords, do anything else. Just wanted to make a note of that because obviously they're kind of one of the crown jewels, if you will, in the industry. Getting at the places where all the passwords are is certainly a target these days. If I move on to the second news article, Teradata. Now, first of all, Teradata has been around in the analytics space for a long, long time. And they've also been available on top of infrastructure as a service, or IaaS, for quite some time as well. But they decided to up their game a little bit and get more like the others in this space, such as Snowflake and some of the others, and get into the SaaS offerings. So, maybe it's Snowflake, maybe it's Databricks, but these are incredibly popular platforms for data analysis. And Teradata just did not want to be left behind in the space. For the third article, Heroku, in part of a blog, announced a couple different things. They announced a public roadmap. It's available on GitHub, and that's really nice. They announced some student and nonprofit programs and open source support. And again, those are really nice. But all that got the attention was what they're calling a focus on mission critical, which also means, what doesn't get focused on? Well, that is the free product plans and inactive accounts. So they are going to start to do some cleanup and basically put a focus on the things that are making them money. And of course, rolling out some programs to help those in need as well. But this did cause quite a bit of a stir in the industry this week. But I think this is one of those things that I shouldn't say we saw coming, but I don't think it should also be a surprise either. So with that, that's going to wrap up Cloud News of the Week. Coming up after the break, we have none other than Tim Wagner. And if you don't remember Tim was the guy in the serverless space that smashed the servers on stage at Serverless Conf a number of years ago. And we're able to catch up with him. And we're going to talk to Tim right after the break.
Datadog is a SaaS, cloud monitoring, and security platform that enables full-stack observability for modern infrastructure and applications at any scale, providing teams dashboarding, alerting, application performance monitoring, infrastructure monitoring, UX monitoring, security monitoring, and log management in one tightly integrated platform, plus 450 plus out-of-the-box integrations with technologies including cloud providers, databases, and web servers. Aggregate all your data into one platform for seamless correlation, enabling teams to troubleshoot and collaborate together in one place, preventing downtime and enhancing performance and reliability. Get started with a free 14-day trial by visiting datadog.com/cloudcast. That's datadog.com/cloudcast. And we're back. And folks, as we have talked about for a number of years, and there's all sorts of different opinions on this, but I think the reality that we've all come to realize over the years is that while public cloud has become this amazing thing, it's changed how we build applications. It changes how we think about kind of all sorts of aspects of technology. What's also emerged is the fact that we still have a lot of applications in multiple clouds. We still have data in multiple clouds. We're figuring out all sorts of new ways in which we partner together. Our applications talk to other applications. So, ultimately we end up trying to figure out on a constant basis, what does all this sort of multi-cloud, multi-application, multi-data mean? But more importantly, how do we wrap our arms around it? And going forward, as that sort of becomes the new normal, are there going to continue to be sort of better ways to deal with these environments, to deal with the reality that, our businesses are somewhat distributed and we need to have our technology sort of match the needs of the business. And so today we get an opportunity to not only talk to somebody who is really a veteran of the industry, has really been an innovator in the industry, but somebody who's really trying to take on this challenge. So really excited today to have Tim Wagner, who is co-founder and CEO of Vendia. Tim, welcome to the show. Great to have you on.
Thank you, Brian. Great to be here.
It's, for anybody who's listened to our show for a while, they know that both Aaron and I were incredibly fascinated with the serverless movement, with Lambda and a number of things. You were there at the beginning of that. We joke around. It's been 5 or 6 years since you were on stage at Serverless Comp, standing over the baseball bat, smashing servers, and really defining that era, defining that technology paradigm. But for folks who don't know you or don't know of your background, give us a little bit of your background, and then really what led you to found Vendia and really kind of get into this space.
Absolutely. So, well, as you say, I've had this history with serverless, and one of the interesting things about it, of course, we didn't have that word, kind of back in the day. I got to AWS, and in that era. So kind of imagine back kind of like 2012, building a robust, scalable, fault tolerant, distributed application in the cloud, which mostly meant building it on AWS EC2 in those days. It took a lot of engineering insight. It took a team of people who really knew how to turn raw servers and other pieces of infrastructure into one of these highly performing distributed applications. And plenty of companies didn't have that capability. So, there was kind of a long journey, kind of from what I started on there into where we eventually got to with what became AWS Lambda and the serverless division at AWS. But it started from a real simple idea, which was, how can we make the power of the cloud accessible to more people more of the time, without necessarily kind of having access to that team of sort of PhDs of distributed systems professionals to go build it, and kind of to democratize access to things like compute in the cloud. And Lambda was many things, and it was a kind of a different business model for AWS. It was a different computational model, but at the core of all of it was this idea of simplicity, right? Of taking away, yes, the servers, but also the scalability and fault tolerance and all those things that AWS folks are really, really good at doing, but maybe all the rest of us, are not, or at least not all the time. And that was now, of course, that feels commonplace. Practically everything AWS is delivering has a serverless flavor to it. Yep. But back in the day, that felt that felt foreign. In fact, I think Andy Jassy's first response to me was like, "What do you mean? It's not EC2?" So it was not an easy sell at the beginning.
Yeah, I can imagine. And today you're you've moved on from that. I feel like we're at a stage of sort of a new generation of we've seen a number of really prominent AWS product managers, leaders are now sort of taking on new challenges. What ultimately led you to go off and start Vendia?
Yeah. So well, let's talk for a moment about what came in between there. So
yeah.
I actually went from AWS down to Coinbase in San Francisco, where I was VP of engineering. And, this is just, caution to the audience here, like we're not going to be talking about cryptocurrencies. So, don't expect my, my recommendations on whether to buy Bitcoin or not. But it was relevant to what eventually kind of led me to found the company, because it gave me this ringside seat into seeing what was going on with distributed ledgers and kind of how they were being built and architected. And things like Bitcoin, Ethereum, but even private ones like Hyperledger Fabric, they are I guess what you might call a one box deploy, right? Like they run on a single server, and that has some advantages because if you're into crypto, that means that server can live outside the US, which can place it outside the, the control of a particular nation state. But the fact that it can run on one machine means it also doesn't really run in the cloud in the same way. It can't take advantage of the cloud, and it can only ever run as fast as one machine can run. So I always tell people, the best and worst thing about Ethereum is you can run it on your laptop, because that also tells you how good it's ever going to be. Forget about proof of work, proof of stake, et cetera.
Yeah.
So I got really excited, working at Coinbase and thinking about, could we kind of put these two worlds together? This promise of kind of blockchain, right? And the thing about it that is amazing is you can take two people, two systems, two clouds, two technology stacks that have nothing else to do with one another, and you can give them a consistent database experience. Right. If you think about crypto, right, like, your holdings and, your holdings are known to all the people who are running whatever those Bitcoin or Ethereum servers or whatever you have. And that was kind of the promise of blockchain. And it was this incredible promise for enterprises who have these data sharing needs. Well, I'm sure we'll get into kind of, what customers are doing with this, right? But, all these enterprises got excited about blockchain, not because of the cryptocurrency part so much, but this idea that it could be a better way to build APIs, to have databases, to share their data with one another. And then the reality of that, the dark side here, right, is it just didn't work well. Ethereum on a good day does about 14 transactions a second of worldwide aggregate capacity. Compare that with a single account in DynamoDB doing, hundreds of thousands, maybe even millions of transactions a second. Right. A lot of, and for much, much less money, right? So a lot of zeros separating those two systems in terms of their price performance. So I kind of asked this, what felt like this really compelling question, could we take the best of the cloud, right? The way something like Lambda or another managed service is built in AWS, and apply that to blockchain. And then similarly, could we take the idea of blockchain and go apply that to applications in the cloud as a way to take data and compute and spread it across different parties, different clouds, different systems, different geographies, and kind of marry those two interesting worlds together. So that was kind of the technical or product genesis, if you will, of what eventually became Vendia at the end of the day.
Yeah, and it makes a lot of sense. Let's put some of the underlying technology, kind of to the side or keep it as an implementation detail. The thing you hear from companies all the time is they go, look, there's a lot of reasons why, my portfolio of applications, the companies we acquire, what one group of developers might want to do doesn't all happen to follow the exact same place. They're not, like you mentioned, as much as Andy Jassy wanted to believe that everything was eventually going to be in AWS, or as he used to say, like in the fullness of time, the reality was, whether it was for geography or whether it was, for a data feature or whether it was for a price or whatever, stuff just happened to be in different places as well as on-prem. And any given cloud was pretty good at making an experience for themselves, but that didn't make it necessarily easier for the reality of what a customer had. So it feels like, we're sort of left in a lot of cases with this sort of mess of the cloud's great, except when I have to have more than one cloud. And it feels like what you're really attacking is like, how do I, deal with that second order problem?
Absolutely. And in fact, it's a great way to think about the nature of the challenge. And I tell people this all the time, like you can, to some degree, you can pick your cloud, you can pick your business partners. What you can't pick is your business partner's cloud, right? Like eventually you end up, if you end up having to share data with someone who hasn't made the same choice you have. And then of course, M&A, large companies, best of breed services, there are lots of reasons people end up with a multi-cloud or polycloud strategy eventually, either getting forced there or it happens by accident. There are lots of paths to it. But even in the best of worlds, even if you were an all-in on AWS shop, no company works in a vacuum.
Right.
There's this wonderful quote out of Amazon Retail. 80% of our critical business data now lives outside our four walls, right? Lives with suppliers, with logistics, right? Yeah. With manufacturing partners, with all these other people. The days when data started and ended its life in your on-prem mainframe are kind of gone forever.
Yeah.
And so, as you say now, like applications, like it or not, they're really multi-cloud, they're multi-party. Not everyone uses those words to describe it. But when you start talking to them, talk to a company like BMW, 35,000 parts go into a car from hundreds of first line suppliers and thousands of second line suppliers. And then those car parts sometimes go to subsidiaries, like Rolls-Royce, right? So they're crossing company boundaries, crossing, wholly owned subsidiary legal boundaries. They're crossing geographic and logistics boundaries. Putting all that together, tracking all of that across all that complexity, call it what you will. It is a multi-party, a multi-geo, multi-cloud application at the end of the day.
Right.
And everybody wrestles with it. As you said, it remains in 2022, one of the hardest things you can ask a team of developers to go accomplish.
Yeah. What do you find? So obviously you're engaged with the market, you're talking to a lot of different companies. At what point do they typically kind of say, look, my pain point feels like it's such that, what you guys do makes sense to start trying to figure out if it can reduce pain or makes things simpler? Like, is there is there sort of a commonality you're seeing, a pattern there's, that you see where they go, yep, we've tried to do this, or we're going to attempt to do this, in which they go, yep, you guys should start helping us because I don't think we can solve this ourselves?
Yeah. And there are a couple of different ways to look at that, right? One is, what are the characteristics of that problem? Like, for example, our customers, they're typically trying to share data, usually with a business partner, sometimes across, major, if it's a big enough company, their internal departments or sub-organizations, can look like partners, of course. And that data sharing usually has a few characteristics. It's real time. So we're on what you might call the OLTP, or the operational side of the house, right? Not on the analytics or BI ML side of the house. So real time. It's typically sensitive, like you wouldn't put it up on all of it up on a billboard, right? It's not a CDN problem. It's not a one-to-many distribution problem. And then it's usually trying to cross some kind of gap. Either it's, between your supplier and you, between you and your logistics, between you and your alliance partners or loyalty partners. If you're an airline, you've got somebody there that you're sharing data with. And so you've got inherently, in some level, a kind of a multi-reader, multi-writer problem to go solve. And when you've got all those things put together, like that's a perfect use case for us.
Gotcha.
And in kind of real world terms, anytime you've got important transactions or workflows, and those can be real world objects, like, for example, you're building a car, you've got an airline passenger and a ticket that's going to, the person's literally going to be moving around in the air on somebody's equipment. Sometimes it's a virtual piece as well, right? So you're paying a mortgage, you've got a mortgage servicer, you've got Fannie Mae involved. That mortgage gets bundled into a security on a secondary market. So it can be any kind of transaction where the workflow, the collaboration, and the data sharing is critically important.
Yeah. I'm curious about sort of the technology, because when I look at your platform, and again, it's interesting. It feels sort of like and maybe this is a bad pun. It feels sort of like this Venn diagram of a simpler way to build applications. It's, serverless is at the core of what feels like how applications get built, and then this sort of global distributed data sharing platform in the back end. What are some of the technologies that are there that either get exposed to your customers or they don't have to know about, but are kind of providing these superpowers?
No, and thanks for asking, because the arc, for me as someone who kind of was there for the serverless revolution and kind of likes being a builder, this was part of what was really fun about it for me. So think about it as a few different pieces here. At the core, we've got to be able to store customer data and artifacts. So we're using cloud databases. So think for example like Amazon's DynamoDB or Azure's Cosmos DB for the scalar data, and then file store. So S3 or Azure Blob Store, for example. And then what's interesting is what we layer on top of that. So one of the things that we need to do is make sure that all that data is consistent in all the different places it has to be. So that might be two different clouds, it might be two different companies, that might be both of those things at once. And so we have a data replication and choreography layer. So here's where I'll introduce the B word. So one of the things we use under the covers is a distributed ledger. So in much the way that like a conventional SQL database will have a write-ahead log, we need a way of shipping the right information to the right people in the right order and ensuring that it kind of gets there in a consistent way and stays consistent over time. So that's where distributed ledgers or kind of blockchain technology comes in for us, not as like an on-chain token or cryptocurrency, but as a kind of an important kind of behind the scenes piece of the way the data is replicated and tracked and then ultimately stored in each of those different systems. And one of the cool things about that is it brings together some really nice capabilities. So what you might conventionally find as an application log, an audit trail log, your application data, maybe a time series table kept separately, we get to unify all of those pieces into a single experience for customers. And so that's one of the nice capabilities of the system. Yeah. And for customers, we try to make this feel as simple as possible. So today, when you walk up to the cloud and you want a database, you basically say, look, here's my create table statement. Dear cloud, please give me back a table that I can use. And we've tried to recreate that experience, only we give you back a table that now magically kind of lives with multiple parties in multiple clouds in multiple places, and yet still kind of keeps all the information consistent in all the different spots that it needs to be, but is driven off that same kind of schema, simple data model and schema at the beginning. And then we'll also generate an API on top of it, because our customers often want to be able to interact with us in an API driven fashion.
Okay. And then the sort of serverless aspects of it, or are those really because you're seeing more and more of these applications tend to be sort of event driven, or is it just they're such that you just don't want to deal with the hassle of managing servers and infrastructure and all that other stuff?
Well, look, there's a part of it. We just did our SOC 2 compliance, right? There is a part of it which is kind of nice, where you don't have to say, and here's our fleet of servers and how we keep them, fed and healthy and secured. Look, serverless really kind of plays two roles here. One of them is in the customer domain or the customer experience, and that one I say with a caveat, because customers don't have to have bought into serverless in order to get value out of what we've done. Like, if you just want to call APIs, that's great. Yeah. You can call them from your on-prem server all day long if that's what you want to do. But if you want to run compute on our platform, we've kind of taken smart contracts out of the world of Solidity and kind of like these crazy hard to learn languages and pushed them back into the realm of cloud functions like AWS Lambda, that are much easier for customers to read, write, maintain, learn, et cetera. You can write them in your own language and so forth. So they feel a lot more like a conventional stored procedure in a database, and a lot less like a kind of a wacky blockchain specific thing. Yeah. But have a way, still have that capability of bringing compute on the platform. And then the other one, which I think is closer to your question, is we use serverless as as our kind of implementation methodology. And this is sort of the secret sauce for us, right? Like we wanted to build something that could have the capability of a distributed ledger or blockchain with the massive data parallelization that you can get in the cloud. And that's something that is best achieved with serverless, because we can spin up vast amounts of silicon and network capacity, use it to send data around all over the place, write to databases, read out with this really, really broad data parallelism, and then boom, the whole thing vanishes if you're not doing any transactions. So we get all that shine through, if you will, of serverless's tight cost enveloping and scalability and fault tolerance without having to recreate that ourselves, right? We get to stand on the shoulders of the stuff I used to do back at AWS, for Lambda and API Gateway and some of those other capabilities.
Yeah.
But that parallelism is the piece that is really, really powerful.
Yeah, and to be perfectly honest with you, the reason I kind of kept poking at that and asking questions about it is, sometimes when we get a chance to talk to the people who really A, invented this stuff, but B, lived with it for a long time, you have a really in-depth knowledge of not only maybe what was always visible to customers or common use cases, but you sort of knew, like, here was the other potential that was there behind it. And maybe it wasn't always, didn't always become visible, or people didn't know, but I wanted to ask because I also sometimes will talk to people and they go, well, our thing does serverless. And you're sort of like, does it really do something powerful? Or is that just sort of a kind of a shiny thing you put on it because it sounds cool? And you know this stuff. So yeah, it's cool to understand sort of I always love when people are like, look, there are so many things behind the scenes that we could unlock with this. And there's all these thoughts we have. So it's cool to sort of, get an insight as to where you go with that. I'm curious, anytime we talk about applications these days, especially like, there's always a certain amount of like, is this something that's mostly for building new applications? Do you find it has a lot of applicability? Because, as we're talking about, cross company initiatives and applications, we're talking about like airplane ticketing systems or, sort of supply chain stuff with parts, like those aren't necessarily just, sort of brand new greenfield types of applications. It sounds like this has an applicability for, things that are already in motion, but maybe can be rethought, reimagined. There's new aspects of it that have to be evolved. Is that fair?
Yeah, no, that's very fair. And we have this little mantra that of green apps, brown data, right? Like the companies are already doing this some way, right? Like by hook, by crook. We replace different ththings. Like, I mean, I'm always happy to come in and replace a failed blockchain experiment. That's always kind of fun. But honestly, more often, like, think about what the competition is the 20-year-old EDI. It's the aging ERP system that doesn't really work. It's the contractor built a public API for us and it's not really working out, in the way that we want it to. So we have an overnight SFTP batch job, right? And it gets things wrong 20% of the time. So then we have a crew of people who sit on top of it and remediate the outcome, in a very manual way. That tends to be the kind of stuff that we're kind of going after here. But honestly, like, any place where people have public APIs, those APIs are doing something, right? They're generally trying to synchronize data with somebody else somewhere. Yeah. And so it's a beautiful, big, broad TAM, but we, especially since we're a startup, right? We got to focus somewhere. Sure. So we mostly look at those. Where is there an enterprise with partners where they already have an established business network? They already have some established data sharing patterns, but they've got some urgency around fixing it. Either it's costing too much, it's taking too long. They want to make it, say, do dynamic pricing, and they can only update the price once a month, or they need a fleet of people to go fix the problems because the data is running 90 days behind. Anytime you hear that, that for us is especially like on the sales and go to market side, right? Is like that's our catnip. When we hear stuff like that, we're like, okay, we can help with that problem.
Yeah. No, and I like that sort of turn of phrase, green applications and brown data. It's easy to sort of remember, but it does highlight the you're not completely starting from scratch, but you're kind of creating new innovation or new opportunities to do interesting stuff. I want to ask you one last question because it'll come up, and you and I talked about this a little bit before we recorded. it makes a ton of sense as we're getting into these distributed type of things. But as you mentioned, you've seen sort of firsthand one of the ways in which blockchain is used, for certain types of financial things and crypto and so forth. And from purely a technology perspective, people would go, it's not the fastest database. It's not maybe the most efficient database. I'm curious as to why you may have chosen that versus some of these other ones that are out there.
Yeah, it's a great question. And one thing I should probably qualify is that what we didn't do was take an existing blockchain technology and then try to kind of put a bunch of lipstick on it and say, we'll find a L2 batching, sharding, whatever solution to try to make it go a little bit faster. Like it really did require more or less throwing the concept away and kind of going back to square one and reimagining it from the ground up in the cloud. And I hinted at a little bit of that earlier. Like part of the reason is the only way to really scale. Imagine you've got a block with 1,000 transactions in it. Mm-hmm. If you have a narrow pipe coming off a single box, you can only pump that data in and out of the system so fast. You're gated by how fast you can get that data on and off a single box. Mm-hmm. If you have 1,000 boxes, right, you can do it in milliseconds. And so here's where the massive kind of data parallelism becomes super, super important. But in order to do that, you have to allow yourself to use the cloud. And to be clear, there are always trade-offs, right? This is the trade-off we made. We can't run, our stuff, outside the public cloud on a single server in some third world country that has relaxed laws around, what you're allowed to do there, mm-hmm. right? Like that's not an option for us,
right?
But that's okay, right? We're not going after a an altcoin here, right? We're building a solid piece of cloud and application infrastructure for companies that don't want to have to re-platform their data themselves, over and over and over again. And so that becomes a kind of a wonderful way to tie some of these things together. Like all our customers value time travel. They all value an audit trail. They all value a clear way of understanding kind of who changed the data and when, and access controls, geospatial sovereignty. Those are all the things you hear over and over again from a company. And building a distributed ledger into this, into the low levels of the system lets you give them that out of the box in the same way that building it serverlessly lets you give them fault tolerance and scale and cost effectiveness, out of the box. Yeah. So that's why those two things became, super important to us from an architectural perspective, even if some of our customers have no idea kind of how the hamster wheels are spinning when in the back room.
Yeah, and that was the piece that was interesting as we were talking about it before. It really almost gets back to the original things that really intrigued a lot of people about blockchain. It was the immutability, the ability to, like you said, to be able to do time travel and what happened and pure validation that something happened, and you've got multiple parties that need to to be able to ensure that something's there. And so, yeah, it's interesting to sort of get back to the purity of what it was intended to do. And then, like you said, apply it to, a much more traditional IT application data environment. Last question. What's the best way if folks want to engage with the team, want to get started with some of these things? What are some of the best ways to either, engage with your team and pick their brain, get started on the platform, all those types of things?
Yeah, absolutely. So you can go come visit us, Vendia.com or Vendia.net. We just bought our .com domain, so we're excited to start porting over to that. And we've got a blog where we talk about some of the stuff like this. So if you're interested in things like, hey, is a blockchain a database? How are they the same, different? What's Vendia up to from a research perspective? So we've got a bunch of interesting information on our blog there. And then if you're a developer or you'd like to get your hands dirty, you can sign up for the platform. Get a free trial there. We've got a free tier anybody can come and join and experiment with a bit. So, love getting feedback and love having people kind of try it out and teach us new things about what it can be used for. So invite any or all of those.
Very good stuff. Good stuff. Tim, it's been great talking to you. It's been kind of, one of these days, maybe we'll do a look back, after you guys go off and be successful, we'll do a look back as to, how did serverless happen? But thank you so much for the time today. Excited to see what you can build. You've got an amazing track record as far as innovation and understanding the market. So thank you so much for the time. Thanks for teaching us a little bit. And folks, on behalf of Aaron and I want to thank Tim for his time. We want to thank all of you for listening every week, for telling a friend, for helping us grow the show and grow the community. And With that, I'll wrap it up, and we will talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.